Hi there, and welcome to this lesson. In this lesson, we'll be learning about indices, indices, and under indices, we'll be learning about the laws of indices. Now, as the lesson progresses, anything you don't understand, be sure to contact your tutor, who would be more than happy to help. And yeah, let's jump right into the lesson, okay? So, indices, laws of indices. Now, what exactly are indices? Now, an indices is the plural form, okay? But then the singular form is an index, okay? An index, indices, okay? So an index denotes the number of times a given number is multiplied by itself, okay? An index denotes the number of times a given number is multiplied by itself. Another word for index is power, okay? Some people call it power. For example, you have 2 to the power of 5, okay? Or an exponent or order. Some people use the term order, okay? But then, for example, we have 2 to the power of 5. 2 to the power of 5 simply tells you to multiply 2 by itself 5 times. And what we have is 2 times 2 times 2 times 2 times 2. This gives you 32. So that is what an index is. But then, what we're going to be talking about in this lesson, we're going to talk about the different laws that govern different operations on indices, okay? So sometimes you may be asked to multiply numbers with indices, or numbers with powers, or divide numbers with powers. And in this lesson, we're going to learn about how you go about doing that. So, for example, we start with the first law. The first law is the multiplication law. So often you'd be told to multiply two numbers like this with powers, okay? So we have 2 to the power of 3 multiplied by 2 to the power of 2. Now, how would you go about doing this? Now, one way you can do this is you can break everything down, okay? And you can say 2 to the power of 3 times 2 to the power of 2 would give you 2 times 2 times 2, i.e. 2 to the power of 3, multiplied by 2 times 2, i.e. 2 to the power of 2. So what we have there is 2 to the power of 3 multiplied by 2 to the power of 2. Now, if you just look at this as it is, I believe you would agree with me that this is 2 times 2 times 2 times 2 times 2, which is 2 to the power of 5. And one way I could have done this, I would have just said 2 to the power of 3 times 2 to the power of 2. I'll just go ahead and add the indices, okay? I say equals 2 to the power of 2 plus 3, or 3 plus 2. And what I have in the end is I have 2 to the power of 5. Now, what are we saying here? The multiplication law says that when you have two numbers raised to the same number, the same number. For example, in this case, we have 2 to the power of 3 and 2 to the power of 2. If you have 2 to the power of 3 and 3 to the power of 5, you can't work with that. The two base numbers must be the same, okay? So we have 2 and 2, but raised to the power of 3 and raised to the power of 2. So whenever you have an instance like that and you're told to multiply, what you do is you add the powers. All right, so x to the power of a multiplied by x to the power of b equals x to the power of a plus b. That is the multiplication law. Now, similarly, if you're looking to divide, okay, so division law, let's say you're given 4 to the power of 6 divided by 4 to the power of 2. Notice we have 4 and 4, okay? We can't have different base numbers. The indices can be different, obviously, but then the numbers, the two numbers you're working with, whether multiplying or dividing, must be the same, okay? So we have 4 to the power of 6 divided by 4 to the power of 2. All right, and one way you can go about with solving this is you can just expand everything. So 4 to the power of 6 is 4 times 4 times 4 times 4 times 4 times 4, okay? And we divide this by 4 to the power of 2, 4 times 4, and we just go ahead and cancel, and what we're left with is 4 times 4 times 4 times 4 times 4 times 4 times 4, i.e. 4 to the power of 4. But then, very easily, I could have just said 4 to the power of 6 divided by 4 to the power of 2 equals 4 to the power of 6 minus 2 equals 4 to the power of 4. So what is the law here? When you have numbers with powers and you're asked to divide them, okay, the same number with powers and you're asked to divide, you just simply subtract the indices. So x to the power of a divided by x to the power of b equals x to the power of a minus b. Okay, so 4 to the power of 6 divided by 4 to the power of 2 equals 4 to the power of 6 minus 2. And these are the two important laws. Okay, if you're asked to multiply indices, you add the indices. Okay, multiplication becomes indices. If you're asked to divide, you subtract. Okay, so division becomes subtraction. And now we have two more laws. Okay, but these laws aren't too important, basically just derivatives of these two laws. Okay, and then what we have, the zero law. What is this about? So let's say you have 3 to the power of 4 divided by 3 to the power of 4. If you decided to expand this out, you'd have 3 times 3 times 3 divided by 3 times 3 times 3 times 3. And basically, if you just cancel this out, everything would cancel out and you'd end up with 1. Okay, but if you're to apply the division law to work in this, basically you have 3 to the power of 4 divided by 3 to the power of 4 gives you 3 to the power of 4 minus 4 gives you 3 to the power of 0. Have you ever had a number to the power of 0 before? Yes, we do have numbers to the power of 0. And then what I'm going to tell you is that 3 to the power of 0 equals 1. Okay, 3 to the power of 4 divided by 3 to the power of 4 equals 3 to the power of 0 equals 1. Okay, and actually pretty much any number you raise to the power of 0 will give you 1, because any number you put in this content would give you 1. Okay, so x to the power of 0 equals 1. So even if you have 1 million to the power of 0, it would give you 1. Now, next law, just another law you need to take a note of, the negative index law. And what is this about? Basically, we have a number like this. We have 4 to the power of minus 2. Okay, now this is very, very strange index. Okay, not very common. So we have 4 to the power of minus 2. Now what is this about? 4 to the power of minus 2. Now I tell you, 4 to the power of minus 2 is the same as 4 to the power of 0 minus 2. Okay, you'd agree with me, minus 2 is the same as 0 minus 2. If you say 0 minus 2, you end up with minus 2. Okay, and then 4 to the power of 0 minus 2 is the same as saying 4 to the power of 0 divided by 4 to the power of 2 from our division law. Okay, and then 4 to the power of 0 divided by 4 to the power of 2 equals 1 over 4 to the power of 2. And here we have our negative index law. You have that 4 to the power of minus 2 is the same as 1 over 4 to the power of 2. And basically, if you have x to the power of minus a equals 1 over x to the power of a. So if you have a number to a given index and the index is negative, so let's say you have 2 to the power of minus 3, it equals to 1 over 2 to the power of 3. If you have 5 to the power of minus 2, it equals 1 over 5 to the power of 2. Okay, so you just take out the negative sign, okay, and you say 1 over the number you have. Okay, so, and yeah, that would bring us, basically we have 4 laws. All right, and we're just going to go ahead now and solve some examples. Example 1. Example 1 says simplify 10 to the power of 4 times 10 to the power of 5. Very simple. And basically what we have is we have 10 to the power of 4 multiplied by 10 to the power of 5 equals 10 to the power of 4 plus 5. We're multiplying, so what we do is we add the indices. Okay, so notice we have the same number. We have 10 to the power of 4 and 10 to the power of 5. Okay, if you had 10 to the power of 4 and 6 to the power of 5, we will not be able to apply the laws of indices. The base number has to be the same to apply the laws of indices. So now we have 10 to the power of 4 plus 5 gives you 10 to the power of 9, and that's it. Very simple, very straightforward. Let's do another one. Example 2, and example 2 says a. Okay, so we're not using numbers now, we're going algebra and we're using letters. So a to the power of 2 multiplied by a to the power of 6. Okay, And very simple, we have a and a, so we go ahead and apply our index law. So we have a to the power of 2 plus 6 multiplication becomes addition, and we have a to the power of 8. Simple, straightforward. Another one. Example 3. And example 3 says simplify 4y cubed multiplied by 5y. Okay, one way you could do this is you can go ahead and expand all the terms there. Okay, so expand the first term will give you 4 times y times y times y times 5 times y, and then you have 4 times 5, and then you have y times y times y times y. Or very simply, we just apply the laws of indices. Okay, so what I'm going to do, basically I have coefficients here. Okay, so 4 times, basically the numbers we're interested, the terms we're going to apply our index laws to, the y cubed, because that's where the index is, and y. Okay, but then I'm going to write y as y to the power of 1. Y on its own, any number on its own is to the power of 1. Okay, and then the next thing I'm going to do is I'm going to multiply the coefficients. So 4 times 5 gives me 20, and then I'm left to just multiply the index numbers there, so 20 multiplied by y to the power of 3 times y to the power of 1. I can go ahead and apply my index law, and I have 2 times y to the power of 3 plus 1. I have 20 times y to the power of 3 plus 1, and I have 20 times y to the power of 4, and what I have in the end is 20y to the power of 4. Simple. Another example, example 4. And example 4 says simplify m to the power of 5 divided by m to the power of 2. And very simple, we're just going to say m to the power of 5 divided by m to the power of 2. We have m to the power of 5 minus 2, and what we have in the end is we have m to the power of 3. Okay, so our division law, division becomes subtraction. So m to the power of 5 minus 2, you have m to the power of 3. Another example, example 5. And example 5 says simplify 30p to the power of 7 divided by 6p to the power of 2. So we have division, but in this case we have coefficients. All right, and basically I'm just going to go 30p to the power of 7 divided by 6p to the power of 2. Our index numbers here, p to the power of 7 and p to the power of 2. We have coefficients 30 and 6. So what I'm going to do, I'm going to divide 30 by 6. It gives me 5. And now multiplied by the result of working with my index numbers there. So 5 times p to the power of 7 divided by p to the power of 2. P to the power of 7 divided by p to the power of 2 becomes p to the power of 7 minus 2 from our division law. Okay, and then we have 5 times p to the power of 5, and we have 5p5. Simple. One final example, example 6. And example 6 says simplify x to the power of 2 divided by x to the power of 7. We have x to the power of 2 divided by x to the power of 7. What we have is we have x to the power of 2 minus 7 gives you x to the power of minus 5. Okay, and x to the power of minus 5 is 1 over x to the power of 5 from our negative index law. And very simply, that brings us to the end of this lesson. Okay, very simple principle, the laws of indices. If you're ever told to multiply, you add the indices. If you're dividing the indices, you subtract the indices. If you have an index to the power, if you have a number to the power of 0, it's always 1, any number at all. And if you have a negative index, it equals 1 over the positive version of that index. So if you have 1 to the power of minus 2 or 3 to the power of minus 2, it becomes 1 over 3 to the power of 2. Simple. That's pretty much all you need to know. And yeah, you can go ahead now and solve the questions on the worksheet. Bye for now.